Hello, ladies and gentlemen. This is Mr. Mayer, and today we are discussing parallel lines, specifically parallel lines using equations. Your learning target for today's video, you want to be able to say, I can analyze two or more equations and determine if they create parallel lines. So let's get right into it. We have two examples to look at today. For example number one, we are going to show that these lines are parallel. So there's a couple things happening. If I'm looking at parallel lines, you got to remember what parallel means. Parallel means that two lines never intersect, and more importantly, that therefore they travel in the same direction as each other. So on a graph, if I'm looking to decide if lines are parallel, the most important part of your graph or of an equation that creates a graph is going to be your slope. A slope tells you the direction of the line. So if two lines are parallel, your slopes are going to have to match. Okay, so that is step one. Your slopes must match. Step two, also important, your y-intercepts must be different from each other. So there's a very simple format that we want to use every single time that we're comparing two equations. You notice right now, they're not looking like the same order as each other. The format that you want to use is y equals mx plus b. Now you've learned this for years. Y equals mx plus b is slope-intercept form, where your m represents your slope and your b represents your y-intercept. Okay, so these are the things, this is the format you want to have these in, because remember, your slopes or your m must match each other, your b's or your y-intercepts must be different. So first things first, I already see this is already in slope-intercept form. Y is alone, check. Your m and your x, these things are side by side and they're ready to go. And your b, last thing, your b is a number by itself. This is perfect. So already I know in my first equation, this is my m and this is my b. Make sure you include the negative. Always make sure you're including negatives here. Okay, so my m equals 2, my b equals -3. So I want to make sure that these two steps are true, are matching for the next equation. My m has to be the same, my slope-intercept has to be different. Okay, oh no. So these are definitely not, this is definitely not in the format that we need it. Y needs to be alone. So the first thing I need to do is I need to make sure I am getting the y alone here. So here's my y part. This is on the same side. So this is the thing that needs to move to the other side first. I'm going to use inverse operations to move something to the other side of the equal sign. So instead of saying -6x or -6x, the opposite of negative or minus is to have a plus or a positive. So I'm going to add 6x. If I do it to one side of an equal sign, I have to do it to the other side of the equal sign. Okay, the whole point is so that these cancel out. They are opposites to each other. The only guy left on this side is the positive 3y's is equal to, is this 9x? No, they're not like terms. I cannot combine them. So I need to make sure I'm putting it in slope-intercept form. Put the part with the x, the term with the x needs to go first. Okay, and then it was a positive 3. I'll just make sure I put +3. So I'm finished. Oh, actually, unfortunately, I need to have the y by itself. No number in front of the y. So in order to get rid of this, remember there's an invisible multiply in between the two things right here. So opposite of multiply would be to divide. Can I just do it on one side? Nope, I know my rules. I have to do it on the other side too. Only to one place? Nope, has to go everywhere. So when I divide every term in this equation. The whole point, again, is that so that those cancel out. I'm left with y equals 6 divided by 3 gives me 2x plus, it was a plus sign, I bring it right down, 3 divided by 3 gives me a positive 1. So let's go ahead and look. This is my m. This is my b. So let's make sure our criteria are matching. My m is 2. My b is 1. Is this working out? Slopes match. M matches each other. Perfect. My y-intercepts must be different from each other. -3 is different from 1. Perfect as well. So therefore, what we are understanding is that, yes, these lines are parallel. These equations make parallel lines. Okay, so that is what you are trying to accomplish here. Let's see if you have it. For our last example, you are on your own. You now are going to decide if the equations create parallel lines. So let's remember our two important steps. Step 1, slopes must match. Step 2, your y-intercepts must be different. Just a clue for yourself. Make sure you're using y equals mx plus b. This is called slope-intercept form. Here is your slope. Here is your y-intercept. Let's see if you've got it. So you're on your own. Go ahead and pause the video and let's work it out and make sure you have it. All right, welcome back. Let's see how we did. So hopefully go ahead and work through, make sure if there's any bumps in the road that you're going through what I did to make sure that you got this correct, okay? Because now we're gonna analyze. Step 1, slopes must match. 2/3 is the same as 2/3. I love that. Don't forget, you need to simplify this 4/6, divide them both by 2 so that you can simplify the fraction. So far, this is perfect. We're on the right track. Last but not least, step 2, y-intercepts must be different. -3 is not different from -3. So since these are matching, guys, we're not allowed to have that. The reason that you're not allowed to have that is because your slopes, your lines cannot be parallel if your y-intercepts are the same, because they make the exact same line. Does that make sense? So since everything is identical between these two equations, you actually have a line on top of itself. And that is not going to create a parallel line. It's the exact same line. There's only one, okay? So hopefully this helped you out. Please tune in to the next video to get some more help. Look forward to seeing you then.